Welcome all. Today let us study about the geological history of the earth. In the previous class we studied about how our planet earth is formed and how it is differentiated into layers like core, mantle and the crust. Today let us know about the origin and evolution of the earth crust. It is studied under how continents and ocean is formed. First one, origin and evolution of the continents. The embryonic continents were formed during vigorous small-scale mantle convection. In this image, we can see that there is a rising current. That is, the partial melting of the mantle produces volcanic materials known as basalts, which comes out, and that is relatively high in silica and consequently would be less dense than the mantle. It would therefore resist assimilation back into the mantle. The basaltic crust would be compressed, thickened, and metamorphosed and partially melted, thus forming continental crust. According to experts of geology and geomorphology, the continents are made up of three basic structural components. They are shield, stable platforms, young folded mountain beds. First, shields. The continents are composed of shields which are huge slabs of granitic rock. These shields are thousands of square kilometers and lie within a few hundred meters of sea level. Shields are composed of highly deformed sequence of metamorphic rocks and granitic intrusions known as basement complex. Most of the rocks are Precambrian, formed under high temperature and highly compressive stress. Next, stable platform. Large areas of basements are covered with a series of horizontal sedimentary rocks. The stable platforms form much of the world's broad, flat lowlands and are known locally as plains and low plateaus. Generally, it is of sandstone, shale, and limestone, which were deposited in ancient shallow seas. At present, more than 11% of the stable platforms are covered with water. Next, mountain belts. The great linear folded mountain belts which are found on the destructive plate margins are one of the Earth's most distinctive features. The rocks of these folded mountains are characterized by folds and faults. Two major mountain belts still in a process of growing. They are Cordillera Belt, that is Rockies and Andes, and Himalayan Alpine Belt. Next, let us study about the origin and evolution of the ocean. The three major ocean basins, that is the Pacific, Atlantic, and Indian, are believed to have originated by the seafloor spreading. They differ from each other in size, shape, seafloor topography, and age. The ocean floor was formed by volcanic activity and faulting. In addition, sediment setting from the ocean blankets of some areas to form flat, featureless plains. It is the ocean floor, not the continent, that is the most widespread surface of the earth. The present oceans have evolved as a result of shifting tectonic plates during the last 200 million years. The origin of ocean can be explained with the help of its features. The major features of the ocean basin are the oceanic ridges, abyssal plains, trenches, islands and seamounts, and continental margin. First one, the oceanic ridges. Oceanic ridge is the most pronounced tectonic feature of the earth. It is essentially a broad, fractured swell generally more than 1500 km wide, with peaks rising as much as 3 km above the surrounding ocean floor. It covers over 23% of the Earth's surface, almost as much as the surface of the continent. The ridge's most remarkable characteristic is that it extends as continuous feature around the entire globe, like a seam of baseball. It extends from Arctic basin down through the center of Atlantic, Indian Ocean, Pacific Ocean into the Gulf of California, a total length of 64,000 km. It is the greatest mountain system on earth. The mountains of the oceanic ridges are nothing like the mountains of the continent, which were built of folded and metamorphosed sedimentary rocks. By contrast, the surface of the oceanic ridge is composed entirely of basalt and is not deformed by folding. Oceanic sediments are thickest down the flank of the ridge but they are thin rapidly towards the crest. Next, abyssal floor. Vast areas of the deep ocean consist of broad, relatively smooth surface known as the abyssal floor. The abyssal floor extends from the flanks of the oceanic ridge to the continental margins, generally lying at depth of from about 3 to 5.5 km. In most ocean basins, the abyssal floor can be subdivided into two sections, that is abyssal hills and the abyssal plains. The abyssal hills are relatively small hills rising from 75 to 900 meters above the ocean floor. The hills are found along the flank of the ocean ridge. In specific, they cover 80 to 85% of the oceanic floor. Next, the abyssal plains are exceptionally flat areas of the ocean floor where the abyssal hills are completely buried by sediments. Generally, they are located near the margins of the continents and spread over the adjacent ocean floor. Next, trenches. A subduction zone where the two plates converge and one slab of the lithosphere plunges down into the mantle. It expressed to the topographically by a trench. Trenches, some of which reach over 11,000 meters below the sea level, are the deepest part of the ocean. Next, islands and seamounts. Thousands of submarine volcanoes occur on the ocean floor, with the greatest concentration in the Western Pacific. Some rise above sea level and form islands, but most remain submerged and are called seamount. They often occur in groups. A guyot is a special type of seamount with a flat mesa-like top surface rather than a cone. Next, continental margin. Continental margins are covered by oceans but are not geological part of the ocean crust. They are composed of continental crust and sediment derived from erosion of the land. This part of the ocean can be subdivided into three major sections. First one, the continental shelf. It is a submerged part of the shield or a stable platform. The gentle sloping shelf extends from the shoreline to the area where the continental margin begins. Its steep descent to the ocean floor. The shelf can be as much as 1500 km wide, with its depth ranging from 20 to 550 meters at its outer edge. At present, continental shelves comprises 18% of the Earth's total continental area. Next, continental slope. From the outer edge of the continental shelf is the beginning of the continental slope. It marks the edge of the continental granitic rock mass. Continental slopes are found along the margin of each continent. They are by far the longest and the highest slope on Earth. They are 20 to 40 km wide. Next, continental race. Continental race is a transitional feature between the continent and the ocean basin. It is gentle inclined surface rising from the abyssal plain to the continental slope. The continental race is apparently formed by sediments deposited at the base of the continental slope. Next, the geological timescale. The geological timescale is an important tool used to portray the history of the Earth, a standard timeline used to describe the age of rocks and fossils and the events that formed. It spans Earth's entire history. The geological time scale, the geological time for the purpose of the determining the age of various rocks has been divided into two eons. They are Precambrian and the Paleozoic eon, and four major eras, namely Precambrian, Paleozoic, Mesozoic, Cenozoic. The oldest and by the far the longest is the Precambrian, which covers about 87.6% of the geological time. Our knowledge about this era is quite much, but our knowledge about the remaining three eras starting about 600 million years ago is relatively more. Each of the eras is subdivided into smaller time units known as periods. The Paleozoic has been has 7 periods. The Mesozoic 3 periods and Cenozoic has 2 periods. Each of the 12 periods is further subdivided into epochs and each epoch into ages. First, the Precambrian era. This is the oldest era of geological history. It is the period of time from the consolidation of the Earth's crust to the base of Cambrian. The term Proterozoic, Azoic and Archean have been used either as synonyms or partial synonyms. The duration of the Precambrian time is probably not less than 4,600 million years and about 88% of the geological time, and during this period a number of orogenies are known to have occurred. The Precambrian rocks are mostly crystalline, igneous and metamorphic, which are extremely complex. The peninsular plateau of India is mostly composed of the Precambrian rocks. The hot climate of the Precambrian period is broken up by a series of ice ages. Seaweeds were the only form of vegetation. During the Precambrian period, life originated in the warm seas. There is no life on land. Thus, the Precambrian rocks contain only a very few fossils of a more primitive forms of life. The Precambrian rocks are extremely rich in metallic minerals, and almost all the important occurrence of iron ore, gold, silver, copper, manganese, uranium, chromium, lead, zinc and mica in the world are found in the rock of Precambrian era. These rocks are, however, poor in the fossil fuels like coal, petroleum and natural gas. Next, Paleozoic era. The era ranged in the time from 600 to 230 million years, a duration of 370 million years. It comprised the Cambrian, Ordovician, Silurian system in the order or lower Paleozoic suberas, the Devonian, Carboniferous and Permian system in the newer or upper Paleozoic suberas. The boundary between the lower and the upper Paleozoic is drawn at 400 million years. The Paleozoic was preceded by the Precambrian era and followed by Mesozoic era. In older works, it may sometimes refer to as the primary era. The major orgogenesis that occurred during the Paleozoic era are the Caledonian in the lower Paleozoic and the Variscan at the top of the upper Paleozoic, together with their accompanying granite intrusion and the metamorphism. The Cambrian period. The word Cambrian came from Cambria, the Latin name of Wales, where these rocks were first studied. In most areas of the world, Cambrian rocks rest on the highly deformed Precambrian metamorphic complex. This period started about 570 million years ago and had a duration of about 70 million years. This period was characterized by shallow seas which covered much of the earth. The seas tended to advance on and retreat from the land areas. Cambrian rocks are found in Wales, northwest Scotland and western England. Similar rocks formation also occurred in Canada and USA. Grand Canyon region. There had been considerable volcanic activity in Europe, but there is no evidence of important mountain building in this period. During the Cambrian period, climatic conditions were moderately warm and equable. Plant life was confined to sea and all the major groups of invertebrates evolved. There was no life on land. Next, Ordovician period. Ordovician had been named after the Ordovis, an ancient Celtic tribe of central Wales. The period extended from 500 to 435 million years, a duration of 65 million years. This period was characterized by widespread volcanicity and onset of Caledonian or orogeny is evident. The seas continued to advance and retreat. Rocks of Ordovician period have been found not only in Wales but also in parts of North America and northwest Europe. Volcanic eruption occurred on the floor of the sea. The climate appeared warm and with no marked climatic zone. Plant life was mainly confined to sea. All life was still restricted to water, but first vertebrates appeared. Plant life did not advance beyond the seaweeds. No life found on land. Next, Silurian period. The Silurian periods had been named after Silures, also an ancient Celtic tribe of Wales. Rocks of this period are exposed on the borders of Wales. The period extended from 435 to 395 million years, having a duration of 40 million years. During this period, the level of sea tended to rise and fall periodically, causing regular change in land areas. Rocks of this period are found in Shropshire, UK, that is Baltic region in Europe, Niagara Falls in Canada and USA. There was less volcanic activity in this period than that in the Ordovician period. Generally warm and equable climate persisted but was exceptionally dry in certain areas. Plants first adapted themselves to life on land but were still leafless. Fossil remains of land vegetation have been found in Australia. New species of vertebrates developed in the sea. Coral reef developed on a large scale. First plant appeared on land. Next, Devonian period. This period has been named after the county of Devon in southwest England. It extended from 395 to 345 million years, having a duration of 50 million years. During this period, land areas increased at the expense of sea. This was a period of extensive mountain building and volcanic activity. Old red sandstone in Europe developed during this period. It was warm and semi-arid climate in northwest Europe and over a large part of North America. With heavy seasonal rain, equable conditions prevailed elsewhere. Earth began to look green as planets with roots, stem and leaves evolved. There was a rapid evolution in vertebrate animals. Ancestors of all modern fish evolved. Primitive shark measuring up to 7 meters appeared. In consequence, this period had become known as the Age of Fish. By the end of the period, the first amphibian animal had come into existence. With land plants to feed on, the first invertebrate animals left the sea and adapted themselves to life on land. They include millipedes, mitre, spiders, wingless insects. Next, Carboniferous period. This is a period named from the widespread occurrence of carbon in the form of coal in these beds. That is why it is sometimes referred to as the Coal Age. It extends from 345 to 280 million years ago and has a duration of 65 million years. Carboniferous rocks are subdivided into two major units, the Pennsylvanian and the Mississippian. Clear shallow seas were widespread in early period. Most of Europe and large part of Russia were under water. Later seabeds began to rise, exposing great stretch of land. Over land areas sinked, producing brackish swamp over much of the Europe and North America. This was the main coal forming period, particularly in northern hemisphere. The land climate was extremely dry throughout most of the period, but in some regions it was warm and moist enough to encourage dense vegetation. Giant evergreen trees reaching heights of over 33 meters flourished in the tropical swamp of the period. Amphibian creatures continued to develop. Marine life, both plants and animals, abound in many varieties. The reptiles became the first creature to breed on land. Certain species of insect developed wings. Next, Precambrian period. The Permian period was named at the suggestion of Marchesian in 1841 from the province of Perm in Russia. This period extended from 280 to 225 million years ago, a duration of 55 million years. It marked the end of the Paleozoic era. This was a period of considerable earth movement. Lofty mountains formed in Europe, Asia, and eastern USA. Contrasting climate conditions persisted, mainly arid in the northern hemisphere with occasional warm and humid zone, but ice age conditions prevailed over much of the southern hemisphere. A seasonal variation of climate temperature developed. Evergreen plants began to decrease in number and deciduous plants able to withstand periods of drought and forest appeared. This period remarked the end of dominance of marine creatures as animals and the plants on land increased. Creatures capable of living on land increased in number and varieties. A great variety of insects began to emerge. Next, Mesozoic era. A major division of geological time extending from 230 to 65 million years ago can be subdivided into three periods, that is Triassic, Jurassic and Cretaceous. The Mesozoic era was preceded by the Paleozoic and followed by the Cenozoic era. The most spectacular elements of the Mesozoic fauna were the giant reptiles. The first mammals appeared at the commencement of this era. Triassic period. The Triassic period has been named after the threefold mountains in Germany. The period extended from 225 to 195 million years ago, having a duration of 32 million years. It marked the beginning of the Mesozoic era. Desert and the shrubs covered the mountains, made up most of the Earth's land area. Formation of the marl and sandstone deposit in the warm seas. Hot, dry conditions prevailed almost everywhere. Climate became wetter towards the end of the period. The first carnivores, fish-shaped reptiles evolved in this period. So did flying fish and the first lobster-like creature. The reptiles continued to dominate life on land. Dinosaurs, no more than 6 inches long, appeared for the first time. The first flies and termites also came on. Next, Jurassic period. The Jurassic period has been named after Jura mountain of France by von Humboldt in 1795. It extended from 195 to 135 million years, having a duration of 60 million years. The seas advanced again. Most land areas consisted of forest and swampy plains with lakes and meandering rivers. Much of Asia and Europe, including the neighborhood of Britain, was invaded by the sea. The climate was predominantly mild, becoming subtropical in some regions later in the period. There was sufficient rainfall to support luxuriant vegetation. Conifers, ferns and tree ferns continued to flourish. Some cycads had flower-like cones, the first step in the evolution of flowers. Reptiles increased in size and variety. The first bird evolved feathers from scales but retained teeth, solid bones and joint-tailed. Mammals remained small and primitive, no bigger than rat, and lived mostly in woodland. Next, Cretaceous period. This period had been named after Greek word Creta, meaning chalk. The Cretaceous period had a duration of about 72 million years, from 136 to 64 million years ago. Land areas bordering the sea consisted of far-reaching swamps. Rivers started flowing slowly and formed enormous deltas. There was widespread deposit of chalk. The climate continued to be mild, causing vegetation to grow abundantly as far north as the Greenland, though parts of Australia appear to be covered by glacier. Growth of deciduous trees like fig, magnolia, poplar, the plane, gain turtles and sea serpents developed. gained reptiles, dinosaur dominated life on land. By the end of this period, dinosaur became extinct. Next, Cenozoic era. It is the age of mammals and modern life. The division of geological time which succeeded Mesozoic era and ends at the Quaternary. The duration of Cenozoic era was approximately 63 million years, from 65 to 2 million years ago. It is commonly used as a synonym for tertiary. Paleocene and Ecocene epochs. Paleocene is the lowermost division of tertiary system, while Ecocene is the epoch of the tertiary period between Paleocene and Oligocene epochs, but started about 60 million years ago and lasted for about 27 million years. Mountain ranges which began to form in Cretaceous period continued to grow. Volcanic activity led to the formation of the Atlantic and Indian Ocean. Vast amount of lava was deposited in the Arctic, Scotland, Ireland and Deccan Plateau of India. Flowering plants including deciduous trees became dominant. The warm climate zone right up to Greenland allowed palms to grow in the region and Malaysia type jungle in the region of the London. Most species of fishes in the ocean took the shape we know today. Many varieties of the modern mammals came into existence, that is, the ancestors of elephants, the rhinoceros, the horse, the pig, and the cattle. Primitive monkey and gibbon appeared in Myanmar. Next, Oligocene epoch. Oligocene epoch started about 38 million years ago and lasted for about 12 million years. Throughout this period, the landmass grew at the expense of the sea. The Alps began to form. The forest dwindled and grassland spread, leading to the increase in grass-eating mammals. The ancestors of modern cats, dogs, and bears evolved. A tailless primitive ape, possibly related to the ancestor of man, also appeared. Next, Miocene epoch. Miocene epoch started about 26 million years ago and lasted for about 19 million years. During this period, powerful earth movements led to the further retreat the sea. The Mediterranean became virtually a landlocked ocean. The European and the Asian landmass were finally joined together. Increased rainfall led to the intense erosion of some parts. Further powerful movements of the Earth's crust completed formation of the Alps and led to the formation of the Himalayas. There was also much volcanic activity. Sharks, particularly abundant during this period, grew to enormous size, measuring over 20 meters in length and having teeth 6 to 15 centimeter long. Increase in the number of apes. Elephants steadily increased in size. Primitive penguins, some as tall as man, lived in Antarctica. Next, Pliocene epoch. Pliocene epoch started about 7 million years ago and lasted for about 5 million years. Continents and oceans began to take on their present form. Land subsidence contributed to the formation of the North Sea, Black Sea, Caspian Sea and the Sea of Aral. Giant shark became extinct. Man-like apes, Australopithecus, which walks upright, spread. Elephants also thrived. Next, Pleistocene epoch. Pleistocene epoch started about 2 million years ago and lasted for about 2 million years. Ice sheets and glaciers covered most of the Europe, America, Antarctica, the Himalayas. Melting ice from the Great Lakes of North America, the tremendous weight of retreating glaciers cut out the fjords of Norway. This was the period of abnormal and extremely climatic change. Marine life was much as it is today. Ape-like creatures developed enough intelligence to make stone implements for cutting up animals they had killed. Primitive man spread to Asia and Europe. True elephants, horses, oxen, appeared. Next, Holocene epoch. Holocene epoch started about 10,000 years ago. The ice continued to retreat, causing the sea level to rise further. Climatic conditions gradually became more equable. In North Africa and Middle East, increasing dryness produced deserts. Marine life was much as today. Man learned to domesticate animals and cultivated plants. Next, the Meghalyan age. Geologists have recently classified the last 4,200 years as being a distinct age in the history of our planet. They have named it as Meghalyan age. We currently live in Holocene epoch, which reflects everything that has happened over the past 11,700 years. Since a dramatic warming kicked us out of the last ice age. Holocene itself can be subdivided into upper, middle and lower phases. The oldest phase of Holocene that exists from the ice age will be known as the Greenlandians. The middle phase of the Holocene will be referred to as North Cambrian and runs from 8,300 years ago up to the start of the Meghalyan. The onset for this age was an abrupt cooling attributed to the vast volume of the freshwater from the melting glaciers in Canada running into the North Atlantic and disrupting the ocean current. The Meghalyan age, the youngest age, runs from 4,200 years ago to the present. It began with the destructive drought whose effect lasted 2 centuries and severely disrupted civilization in Egypt, Greece, Syria, Palestine, Mesopotamia and the Indus Valley and the Yangtze River Valley. It was likely triggered by shifts in ocean and atmospheric circulation. The Meghalyan age is a unique among the many intervals of the geological timescale in that its beginning coincide with the global cultural event produced by the global climatic events. In the next class, let us study about continental drift and plate tectonics.